Hi guys, welcome to part 16 of our series on coding a relational model for Dogen. It's been a while since part 15 actually, and one of the main reasons why is because first is because there was lots of stuff going on, so I didn't really have a lot of time to dedicate myself as I should. But even though I did quite a fair bit of coding since we last caught up, I didn't really record much. The reason why is because, as I hinted in the previous videos, I've noticed that coding whilst recording videos is not most suitable for complex tasks. It's okay for certain tasks and you can kind of get away with it, but it's difficult to actually think about complicated problems whilst at the same time talking about things. So what we've done this time instead is try to get the big things out of the way and then use the videos more to discuss the approaches rather than try to do the approaches at the same time. I know certain people are quite good at doing this sort of thing, coding while talking and so forth. It's not my strong skill, as I've noticed now. It just basically means that coding was going a lot slower, and given that I don't really have a lot of time, can't really afford to spend too much time not actually producing code. So I don't quite remember where we left things off, but what I'll do is I'll just do a quick tour of where we are now, and then hopefully that will make sense from where we were before. So if you remember, originally we used to have a tracer, and the tracer would have these sort of backends, which were really glorified backends at the time. But I had mentioned that I was really keen on creating an interface for a backend, and to make sure that then we could implement that interface in terms of the different technologies that we've got. So that's been realized now. So we have a tracer, and the tracer is composed of the backend. The backend is an interface, and it talks to things via strings, and then it's implemented via different types of backends. So the first one is the one we already had, which was the file backend, and the second one is the relational backend. Now, since we last spoke, the relational backend has been moved into the relational model, as you can see here, and we created this notion of factories, the backend factory. The reason why is because we couldn't really create the backends until we had access to things like the options. If you remember, we have this sort of object that gets generated when Dogen is bootstrapping. It contains all of the configuration options, and that tells us how to instantiate the backends. So this is part way through the processing, well, not part way, but in the beginning of the processing pipeline, I guess. What it isn't is not doing the initialization phase, which is where we tend to register all of our sort of dynamic aspects. So in order to solve that problem, what we decided to do is to create these backend factories, and the factories themselves are registered very early on, as we register other things like via the initializers. Eventually this is going to be dependency injection, but we haven't had time to do that. So the initializers are responsible for registering the backend factories, and the factories then can be used to create backends when we're ready, when we've got all the information we need, such as the configuration. So this solves that problem of initialization. We also have the backend factory registrar that keeps track of all the backend factories, and we now have a much neater solution for when we try to request a relational backend and it's not available. So if the relational model is not enabled, then the relational backend and the relational backend factory are just not going to register. And if they don't register, when you request it from the factory registrar, it will just tell you, sorry, you requested a backend that has not been registered. So it's much nicer than theories like the null backend and all sorts of other things that we were doing before. Didn't really make a lot of sense. This is a bit more sensible now. The other thing we've also done while you guys were away is we created a log backend, and this enables us to upload a log file into the database, which is a useful thing to do, as I'll show you in a minute. So with this, so the other thing to notice as well is our log model is now well, literally 3 elements, three different types. This is dramatically simpler from what it was before, and it illustrates 2 points really. The first point is that many times, and I'm guilty like everybody else, many times we spend time designing things before we have use cases, and it's almost always a really bad idea, because you can come up with all sorts of brilliant vaporware solutions that work really well in theory, but it's only really when you start making use of those types, it's only really when you start uploading data to the database and start extracting fields and so on, that you really start to understand the domain that you're trying to model. So what we found out unexpectedly is, well, not unexpectedly, but expectedly, is that many of the types we had created that sounded brilliant at the time are actually not required, because Postgres already has very clever ways of dealing with JSON, so we can extract a lot of the information we want from the JSON fields. And if we do require some stronger types, if we require some tables to encapsulate some of that information, we could just do that via regular SQL. So we don't really need to worry about ORM for that. So from an ORM perspective, really all we need is some way of talking about transforms, some way of talking about runs, and then some way of dumping our log file. With these 3 types, we kind of more or less encapsulated or modeled everything we needed. Which was also quite a positive thing, really. Okay, so I think that's kind of the big changes that have happened since last time we spoke. So what I'll do now is I will just quickly show you some of the queries that we've been using. Just gonna delete all the stuff we got here. Some of the queries we've been using, it takes about 3 minutes to upload all the data into the database for a run. So I'm just going to make use of whatever it is that we had there before, so we don't waste too much time. So if and I'm just going to use the Emacs interface for SQL. So as you've seen here a second ago, we have a run event. And so in the run events, we basically collect information about a given run, such as start time, its end time, and so forth. One thing we noticed is that in order to make this work properly, because the fields we use in JSON are just so large, we ended up having to truncate them into varchars, because otherwise what tends to happen is Postgres and Emacs, should I say, it just makes Emacs work really, really slowly. We can have as much as say 100 characters. That's not too much of a problem. But once you start pumping megabytes worth of data as a column, particularly a long column, Postgres starts to get really, really upset. And so we end up actually just casting these to varchars and just limiting the size of the varchars. What else do we have? We also have the logging impact. I'll just output the logging impact and the tracing impact. These are fields that we had already previously in our existing tracing, and we just copy them across. We also are able to output the version, I believe, of Dogen that was used. Perhaps not version. Actually, it should have been version. Oh, maybe I forgot a comma. So there you can see the Dogen version. I'm just trying to collect some of these queries in a kind of a nice collection of queries that we're going to convert into stored procs at some point. Oh, actually, one thing that's probably worth mentioning is we created a new command line option. I'll just clean this up. And the tracing, we created a couple actually, now I mention it. So there's the tracing run ID, which you can leave blank. It defaults to GUID. We should probably add that to the comments. It defaults to GUID, and if you can supply whatever you'd like there, provided it's unique at the moment in the database. And we also have a generate database schema, which, if true, will delete everything in the database and recreate it. so it's useful every time we change the schema. The GUID that I mentioned a second ago is used here for the run ID, and once you have a run ID, everything on that session gets tracked with that run ID, or tagged, I guess. So for example, this will show me all the runs. There's only one. Oh, and the reason why there's only one, I think, is because at present, or at least last time, I actually enabled the creation of the schema, so we only have one single run at the moment. So let's say I'd like to see all the transforms in the run. So as you can see here, this dumps a lot of information. With all the transforms, you could see the top level transforms as well, which is this guy here. It shows you the start and an end, and there's only 2 real top level transforms. And then what you can do is you can follow the transforms via the parent relationship. So for example, in this particular case, I took this transform instance ID, oh, actually probably this one, to be honest, and what I'll do is, for good measure, I'm just going to demonstrate by updating this to that. So as you can see here, we take the parent transform ID, and it shows us all the children in it. In this case we have 2 children, which is these engine transforms extraction model sets. And in there we could then continue with exactly the same logic by saying, okay, show me your parents. And as you can see, you end up where we are here. Show me your children, I mean. Sorry, I'm still under the weather, so my voice is still a bit croaky. And so forth, right? So you can see as we can start drilling down. And the interesting thing, of course, is that as you can see here, you can see that we have a payload, a JSON payload, that tells us what's inside of that transform. And we also know the type of that JSON payload. So let's say, for instance, that I would like the details of this transform here. And what I could do is I could simply do select JSON be pretty of the payload from the transform event, where the transform instance ID, I probably can't be bothered to type all of this, so is equal to what we have here. And we also want to make sure we only get, say, the we shouldn't really call this case the event type, and we just say the event type equals 1. Actually, before we do this, let's just say we just do a quick select count. One annoying thing at the moment is that we are using the quotes for naming fields, and that actually becomes quite annoying after a while. Okay, so now the only slight downside of this is, okay, we're lucky that that's quite empty. The only downside of this, as you'll see in a second, Emacs is not exactly fast when you start running these really long previews with very long JSON. So as you can see here, this is actually quite disturbingly slow, really. Like I said, the problem is mainly to the fact that we're using very large columns. As you can see here, these are 41 characters long, and because of that, Emacs gets a little bit upset. So this is going to take quite a long time to run. So the trick so we found is to make sure that when you select JSON, you actually select exactly what you need instead of selecting lots and lots of stuff. But of course, sometimes you need to do these queries just to see what's in the JSON in order to explore. I'm going to try to actually stop this query. This works sometimes, a Control C with Emacs, not always, I'm afraid. Let's give it a go and see if we get it to stop. Whilst this is doing its thing, as you can see, it's still going. Sometimes you need to actually tell SQL to stop. Hopefully it will stop at some point. So as you can see, this is actually horrendously slow. It's not too bad once you know what you're looking for in the SQL, as we show in a minute, but it's not ideal when you're exploring. It's particularly annoying that Control C doesn't seem to stop Emacs. So what I'll do is I think I'm just gonna kill and we can just resume our SQL Postgres. Sadly our history is lost. Again, not entirely sure why it's not recording history. Maybe it's because I keep killing it. Hopefully we can at least continue the queries through here. We need to ensure our search path, excuse me, it's never ending cold, it's not quite gone yet. Right, okay, so yeah, like as I said, you just have to be slightly careful when you dump very large amounts of JSON, particularly very long line JSON. But it kind of works. So once you really know what you're querying with the JSON, it's not too bad. So as an example here, I'm just going to obtain a transform with some dia on it. So if I just ask for all the transforms in this run, you can see there's a few. If we just look for injection.dia somewhere, injection.dia decoding transform, this doesn't look too bad. Let's just grab the transform ID for this and plug that into this guy here. Perhaps we let's try 2. Okay, well in this particular case we are asking for the JSON-B. As you can see, because the columns are so small, the JSON-B is extremely quick. It's only when you got really a 4K column length that it really becomes a bit tricky. And sadly you tend to find out after you run it. What I actually meant to do is to run this guy here. And I was hoping that we'd have some let's just toggle truncate lines. This is actually a meta model, so that's not going to help us. So let's look for some kind of injection. So that's a decoding transform. Put this space. Wonder what's the original transform. It should have really been. Oh, yeah, that looks about right. Oh, I think the problem is we might have just used the parent transform rather than the child. Right, okay, that's it. So we just used the parent transform, which meant we had a diagram with a completely different type. So as you can see here, this is a great example of how to extract information from JSON. So all I've done there is I've created a subselect here that gives me sort of an array view of all the objects in a layer. So I can query these objects in dia formats, but converted to JSON. And then from there I can start to extract. I mean, I call this crap, it could be anything, just call it objects, make it slightly more sensible. Hopefully it's not a reserved keyword. So if I just, yeah, as you can see here, I just basically am extracting from the JSON. I'm just extracting fields from the JSON, and because it's a subselect, this guy here is returning me objects, and then I can just go and pick fields in that object, which makes it really easy to obtain things. And another really useful thing to do is, as you've seen a second ago, we were talking about this particular transform, and as you can see here, there's a start and the end of this transform. So if I just gather, well, actually, to be honest, we could probably rerun this query. So if I just say select timestamp from transform event where transform instance ID is this guy here. Actually useful to just write the queries in the Emacs buffer, to be honest, because then we don't have to write it again. As you can see, can you imagine we are going to convert all these to stored procedures at some point. So as you can see there, you can see for this transform, you can see its start and end time. Now you can do something really clever with this. You could basically say, well, now I know this transform started and I know where it ended. What did Dogen write to the log during this interval? Now again, this is probably going to be a bit long. As you can see, some of these are multi-lines. Of course, we took care to ensure we converted this to only 100 characters. But yeah, you can see here, this just basically gave me a filtering in the log for the things that have occurred during that timestamp, during those two timestamps, which makes it really easy to filter the log now to figure out what happened in the period that my transform was active. Of course, I don't need to get all the components. I could easily say, well, actually I'm only interested in the injection side of things. So I could do something like this. As you can see here, this is just filtered my log components now to the things that have injection in them. So whilst we haven't actually used this to troubleshoot, you can already see that the power of this approach is just immense. We've got the entire pipeline of Dogen, every single thing that Dogen has done in a relational model now. And we've already started to see how we could quite quickly create queries that enable us to obtain pretty much anything we'd like. And of course, because a lot of the stuff we dump into the log is in JSON format as well, nothing stops us from doing things like extracting JSON and then JSON BigQuerying them. I mean, we knew that this was going to be powerful, but it's only really when you start working on this that you start to realize just how powerful this is. For instance, you can see here, I can see the die object here for O0, and now of course, as you've seen a second ago, I could quite easily try to figure out where this O0 object is. You've seen this a second ago. There's my O0 objects, and if I, for whatever reason, decide that I would like to see the contents, could probably do something. Something like this. I haven't tried this before, but I assume I think it's actually doing the whole region. But let's say I'd like to know the contents of a given dia object. Interesting enough, doesn't seem to be listening to my... Let's just make sure this is actually... Oh, I think we just probably need a semicolon to tell dia to tell. So okay, right. I think the problem here is, well, this is just to do with the syntax. The reason why this didn't work is because you can't just you can't actually just say as object and then filter in the object. That doesn't work. The reason why is because there's some syntactical problems in order to obtain that. But of course, I could easily say something like this. It's going to take us a while to get to grips with and now you see I forgot to do the classic ensuring that the size of the object is not too large. But so you see here we're seeing the contents of this object, and of course we still have our friends such as JQ. So I could easily obtain this very large JSON and then JQ dot it. And then now I'm in JSON mode, and of course here I've got access to everything inside of that object, such as the coordinates, and then of course we have JQ interactively in Emacs, so we could easily say do the usual querying. So I could, for example, say show me all the attributes for this object, and of these attributes please tell me the name of the attributes. Well, of course you have to make sure that you're going inside the object correctly, but you can see from here we can easily once we've zoned into what we're looking for, we can easily then start to drill further and further until we find what we're looking for, and it is really, really powerful. Even though we're only scratching the surface at the moment, you can already see this relational model is going to be extremely powerful. So I guess from a perspective of what we set out to do is we've kind of achieved the main objective. We've got all the data in the database, in the relational database, but we haven't quite finished, because if you remember, the objective of this relational model was to try to allow us to figure out why it was that our attempt to express the registrar was failing somewhere in the pipeline. So we're going to do for the next episode, and I'll probably do a summary like I've done with this one. What we're going to do is we're going to start taking all these queries, all these many queries that we already created, and start creating stored procs for them, functions. And then what we'll do is we will follow through these objects in the pipeline. I mean, there's already things that we think that we are going to be necessary, such as, for example, the ability to track an object. For instance, remembering its dia ID, so that I can then go back and find that object, and so forth. It would be nice to have all of that in, and then to be able to say something like, at which point do we stop seeing these objects in the pipeline, for instance. So what we'll do then is we'll come back with the next episode of the video once we've started making use in Anger of all this functionality, and demonstrating that it actually works as expected. I'm sure there's still quite a lot of bugs, but I think the core of it is in. Alright, so that's all for this very short video. Hopefully the next video will be slightly more interesting, because we will use all of this stuff in Anger. Right, thanks for watching.